Yes, hello everyone, and my name is Dullah Mzungu. Welcome back to our class, and today I'm going to talk about the chemistry. The topic is about redox reactions. I'm going to tell you in a nutshell what is redox reactions, and also I can show you how to reduce potassium manganate 7 into manganese 2 ions step by step. Also, I can show you how to balance these reactions in redox. Redox reactions are just reactions whereby elements in the chemical reactions tend to lose or gaining electrons, and which tend to cause increasing or decreasing in oxidation number. This can happen in two environments, whether basic or acidic. Redox reactions means reduction in the oxidation reactions. So reduction is just gaining of electrons, while oxidation means lose of electrons. If you forget this, just remember the acronym say GEL and LEO. GEL means gaining of electron, it is reduction, while LEO means lose of electron, it is oxidation. Also, oxidation means gaining of oxygen, while reductions, you lose oxygen. This can be balanced by using half ionic equations, and today I'm going to show you how to balance these reactions. Then you can get to know about these redox reactions. In the redox reactions, one element or group of elements tend to be oxidized, while another one tend to be reduced. That's why I say there is reduction in the oxidations. So today I have potassium manganate 7, and also I have sodium sulfite. This is a very strong oxidizing agent, while this one is a reducing agent. I have sulfuric acid here to put the reaction in acidic medium, because my point is I want to show you how can I reduce potassium manganate 7 into manganese 2 ions. So these reactions to be gone well, I should always put in acidic medium. That's why I'm using sulfuric acid here. In the first conical flask here, I'm going to pour my potassium manganate as a strong oxidizing agent. It is dark purple in color. This color is for permanganate 7. And this one is reducing agent. Sodium sulfite is supposed to reduce this one into manganese 2 ions. So first it should be in acidic medium. So also I have here my sulfuric acid that I can supply to my solutions of permanganate already. Now I have the mixture of potassium manganate 7 plus sulfuric acid. Now it's in acidic medium. I'm going to add now the sodium sulfite and to shake well to see how it can be. Getting the clear color. So this is a color for manganese 2 plus ions has been reduced. It means in these reactions the permanganate 7 has been reduced to manganese 2 ions. 8 hydrogen ions has been supplied here to remove oxide from the complex and to get the manganese 2 ions. Very clear now. See, this is my first conical flask which having manganese 2 ions. The reduction reaction has completed. Sometimes people asking what happening if you cannot add sulfuric acid in a conical flask here in the mixture. So I'm not adding any sulfuric acid because I want to see what can happen if I cannot apply sulfuric acid. So I'm just pouring my reducing agent, which is sodium sulfite. Now it's just going like a brown color. This is manganate 4. Means there is no enough hydrogen ions to remove oxide from the complex. That's why still oxide remain on the manganate 4. And sometimes you can contaminate your solutions to the basic solutions. For example, now here I'm going to pour my potassium permanganate. Then I add my basic solution of sodium hydroxide to raise up the pH, to put in basic form. Then I add my reducing agent here. Now it will be green. So this green means what? It's manganate 6. Means there is no any hydrogens to remove oxide from the complex. The first one is just a manganese 2 plus ions, that is complete reduction reaction, and this one is manganese 2 dioxide, that is not complete because there is not enough hydrogens to remove oxide from the complex. Or the last one, it is just a green in color, which there is not even 1 hydrogens to remove this oxide from the complex. The reaction of this one has been supplied 8 hydrogen ions to remove this oxide, while this one has been supplied 4 hydrogens and this one there is no any hydrogens. This is how to reduce manganate 7 into manganese 2 ions. Why are we using sulfuric acid instead of other acids like hydrochloric acid or maybe nitric acid? So the reason is we're using sulfuric because if you use nitric acid itself is a strong oxidizing agent, so it will interfere the reaction. That's why I recommend to use sulfuric acid. And hydrochloric ores having the chloride ions can be oxidized to produce the chlorine gas. That's why we recommend to use only sulfuric acid. This is how to reduce manganate 7 into manganese 2 ions. But also I have the manganate 4 and then manganate 6. That is incomplete reductions, but this one is a complete reductions. Finishing now showing you how to reduce the manganate 7 into manganese 2 ions. If in case you're doing titrations, it means you can take your solutions, titrate until the reaction complete. So still in this conical flask having more reducing agent, that's why it won't change. But once you continue planet, it will change the color. Now the reaction will complete. So now it means there is enough oxidizing agent until the color changed it to the color of manganate going to brown. So this is for those who are doing titrations if you want to balance these equations of redox reactions. But now I'm going to show you how to balance these reactions of redox reactions by using the half ionic equation. I'm going to use the same materials for manganate and sulfide. As we know that, first thing is to separate these equations into half ionic equation. So you should know which one is oxidation and which one is reduction. We know that manganate 7 is a strong oxidizing agent, so this must undergo reduction. This one, sulfide, is a reducing agent, so it will undergo oxidation. This will be reduction and this will be oxidation. Manganate reduced to manganese 2 ions plus. This is reductions, while sulfide oxidized to sulfate. This is oxidations. After separating these equations into half, now you know which is oxidations, which is reductions. Now you're going to balance any atom apart from oxygen and hydrogens. So when I'm checking my first equation there of the oxidations, I have one sulfur and one sulfur in both sides, means has balanced it well. While in the second equation of reduction, I have manganese 1 and this side manganese 1, it means has balanced it well. Atoms balanced it well. Next step is to balance oxygen. You're going to check number of oxygen in both sides, right side and left side. Then you check which side needs some oxygen. You're going to add appropriate number of water molecules to the side which are missing oxygen atom. So if I'm checking my reduction equation of permanganate, I can see on the left side I have 4 oxygen, while on the right side I don't have any oxygen production side. This means I'm supposed to add 4 water molecules to the right side to make sure I balance this oxygen now. So it will be 4 oxygen to 4 oxygen, balanced it well. Now I'm going to the oxidation reaction of sulfur. I have 3 oxygen to the left side, also I have 4 oxygen to the right side. This means this side needs 1 oxygen, and I'm going to add 1 water molecule to this side and balancing them to be okay. So now I can see oxygen has been balanced in both equations, above and this one second, meaning in the oxidation and also in reductions. Next step is to balance hydrogen. Again, do the same procedures. You just try to check the hydrogen atoms in both sides. Then the side which having less number of hydrogens, you're going to add hydrogen ions. If I'm checking now in my reduction equation, I have 8 hydrogen ions to the production side. Well, in the reaction side, I don't have any hydrogens. So I'm going to add 8 hydrogen ions to this side of reactant and to make it balanced well. So I have 8 hydrogen to this side and also 8 hydrogen to the production side. If I'm going to the oxidation equation, now I can see I have 2 hydrogen ions to this left side, but there I don't have any hydrogen. This means I'm supposed to add 2 hydrogen ions to this side also. Now has been balanced it well. After balancing atom, oxygen, hydrogen, the next step is to balance charges. You add up all charges in both sides. Then the more positive side, you're going to add the appropriate number of electrons to make it balanced it well. Let's check now on the reduction. I have -1 to the manganate and also I have +8 to the hydrogens. When you plus here you get +7, while in the right side I have +2, but in the water no charge. It means +2 by +7. This side has increased or more positive by +5, so I'm supposed to add 5 electrons. to make it balanced well. When I'm going on to the oxidation equation, I can see now I have -2 to the sulfur and -2 to the sulfur here, balanced well, but there I have +2 in the hydrogen ones. So this side, it is more positive by 2. I'm supposed to add 2 electrons to this side to make it balanced well. Now it's okay. All things is balanced well. The last step is to add up those equations together to get the overall redox reactions, which is well balanced, and I'm going to balance in acidic medium. The first thing is now you should make sure electrons in the first equations and the second equations are look similar in order to be cancelled out. So when I'm checking now in the first equations of reductions, I have 5 electrons, while down here I have 2 electrons. So you should times the number of electrons in the reductions to the oxidations. The same to the oxidation times the reduction equation by 2 to make it balanced well. It will be now 2 permanganate plus 16 hydrogens plus 10 electrons, giving us 2 manganese ions plus 8 water molecule in the reduction reaction. While in the oxidation reaction, I'm going to times by 5. That will be 5 sulfide plus 5 water molecule, giving us 5 sulfate plus 10 hydrogen ions plus 10 electrons. So now I can see 10 by 10 electrons cancel out. We have 5 water molecule to the right side, and you have 8 that will always cancel out. We have there 16 hydrogens, they have always 10, always cancel out. Then we get the acidic equations well, balanced well over redox reaction equation. So now, how if you want to balance in basic medium? You just simply add the number of hydroxyl to neutralize hydrogen ions to these reactions and to get water molecule. So we add this 6 hydroxyl to cancel these hydrogen ions, then you can be clear getting the water molecule. Now the reaction has been balanced well in basic and acidic medium. That was just a little bit about the redox reactions. I've been taught to you about the what is redox reactions and then how to reduce permanganate 7 into manganese 2 ions, and also shown to you how to balance these reactions. Thank you very much. Welcome again to our class. Bye bye.